Here in example 316, we're looking at the idea of unknown rate, so solving for an unknown rate. So Jessica here wins the Illinois Mega Million jackpot. The jackpot was $52 million, which is actually modest for Mega Millions these days. We've seen it get up to almost even over $1 billion. But in any case, she can receive the prize in the form of 26 annual payments of $2 million at the beginning of each year. So annuity due. 52 million here is the total winnings, or she can take a lump sum of 28 million immediately. We want to know, the question is, what interest rate makes the present value of these two equal? So the present value of the immediate payment is just 28 million. And the present value of the annuity, it's a $2 million annuity per payment, so it'll be $2 million. It's an annuity due, so it's going to be an A dots. And there are 26 payments, so A dots angle 26 at I, and then we want to know what I is. So if you wanted to solve with formulas, then you could plug in the formula for A dots angle 26 at I, and you could solve for I. That's more work than using the TVM keys. So let's see. I won't go through this. You remember the formula there is 1 minus v to the n over d, and then you can use the formulas to substitute d for I. So you can solve for d, and then you can use formulas to transform d to I. So first of all, if we want to use TVM keys, we want to change to begin mode. So remember, that's second begin, second set, second quit. Our N here is going to be 26, got 26 payments. Our IY is what we are computing, the interest rate that the state uses to make that payout. Because when you win the lottery, the amount that they quote you is not the amount that you get immediately. It's the total payments from the annuity. It's the total of all your payments. So they're really quoting you not the present value of the annuity, but the future value. Well, even not then, just the sum of the payments. The future value of the annuity would be different. That would be if you took one lump sum at the end of the 26 years. But yeah, they're quoting you the sum of the payments. Our present value would be the lump sum that we get now, 28 million. We can consider that as cash inflow, and the payments would be against that, so they need an opposite sign. So in exchange for payments of 2 million, so this would be negative 2 million. Future value is not used, so that's a 0. So enter this into your calculator in begin mode and compute your IY. You should get 5.82 with some extra decimals, so 5.82%. Now, once you get done with that, make sure you do second begin, second set, second quit to do your reset. Otherwise, it messes up everything after that. So that's an unknown rate problem. So anytime they're asking what interest rate. Here in example 317, Gloria has an estate that's going to be divided equally and invested at an annual effective rate of I as follows. Her only son receives level annual payments for 15 years. So level annual payments, 15 years. Compassion International is going to receive the remainder of the estate as a perpetuity with level annual payments, half the size of those received by her son, and then starting with a payment 16 years after her death. So the year after the last payment that her son gets. And then we're computing I. So how do we attack this? Well, first of all, we need to take into account here the divided equally. So divided equally means that they have the same value. So that could be the same value at any point in time. The most convenient point in time for us is going to be at inception, so when she passes away. So we're going to set PV1, that's for her son, equal to PV2, which is the amount that compassion receives. So it says level annual payments here, and it doesn't say, at the beginning, at the time of her death. So we should assume that this is an annuity immediate. So the present value of that annuity is going to be, we don't know what the payment is, but we know the ratio of the payments. But the present value of an annuity immediate is R times A angle N. So this would be A angle 15 at I, which is that rate we want. And then PV2, this is the present value of a perpetuity. And remember, present value of a perpetuity is just, with payments R, is R over I. So these are going to be payments half the size. So this is going to be 1/2 R over I. And then though that would value the annuity, the perpetuity at inception, which is going to be at time 15. So this whole thing has to get discounted 15 more years. So times v to the 15. Right? Because if we draw out a time diagram, we've got 0, 1, 2, up to 15, 16. So her son gets payments of R. We're going to consider this annuity immediate. So payments of R at time 1, time 2, up to time 15. And then the perpetuity starts with payments of 1/2 R, and that just keeps going indefinitely. So the inception of the perpetuity is here at time 15. Got to discount that 15 more periods. So now we can substitute in the formula for A angle 15. First of all, the R's will cancel off both sides, right? So then A angle 15 is 1 minus V to the 15 over I. And then that's going to equal 1/2 V to the 15 over I. Okay, then we can multiply both sides by I. So these guys cancel. So now we've got 1 minus v to the 15 equals 1/2 v to the 15. So now bring this negative v to the 15 over, just solve for v to the 15. So we get 1 equals 3/2 v to the 15th. So multiply both sides by 2/3. V to the 15th is equal to 2/3. And then V is 1 over 1 plus I. So we've got 1 over 1 plus I is equal to 2/3. Invert both sides. So 1 plus I is equal to 3/2. Oh wait, I get a 15th power. Forgot my 15th power. So let's see here. Yeah, we can invert both sides. So the reciprocal of 1 over 1 plus I to the 15th is going to be 1 plus I to the 15th. Right? Because 1 to the 15th on the top is 1. 1 plus I to the 15th is on the bottom. And then reciprocal on this side, 3/2. And then just take a 15th root. 1 plus I is, whoops, not 3/3, 3/2. And then we get a 15th root on both sides. So I'll do a 1/15th power. It's going to be easier to enter in. And then bring the 1 over as a negative. So -1. And we have I. So we just have to plug into the calculator, and if you do that work, you'll get approximately 0.0274, so 2.74%, and that is in the range for D. So this was one where we really had to use the formulas, and the TVM keys didn't come in handy for us because we had too many unknowns. We didn't know what I was, and we also didn't know what R was. And then section 3J on varying interest, I'm going to have you guys read that one on your own. And that wraps up chapter 3, which is all the basic annuity stuff, which will let you finish the next homework.